Introduction to dot product. Previously, we learned how to resolve force into components. These components were rectangular components. Rectangular components because the axis or the components of the force are perpendicular to each other. They make 90 degrees between each other. So the axis X and Y are at 90 degrees of each other. And that's why we were able to resolve this force into two rectangular components. So if we have two perpendicular axes and we've got the force applied, that force is making an angle theta between the axis or between the component of the force. Now we were able to resolve that force into two components through taking the component on the x-axis, the force along the x-axis equal to F cos theta, and the component along the y-axis equal to F sine theta. The question now, what if x and y are not perpendicular to each other, are not at 90 degrees from each other? Therefore, if we having x and y here, x and y, and they're not at a right angle, and the force is applied, that force will make two different angles in there, two different theta. So theta 1 and theta 2, they both are not equal. They will be equal only the magnitudes of the x and y here. We can say they equal only if they were perpendicular to each other. But in this case, they're making theta 1 and theta 2. Therefore, to solve for the component along the x-axis, we say, again, we make a right angle triangle. And we say that is F cos theta for the force exerted along the x-axis, and for the force or the projection along the y-axis, that will be again F cos theta 2, because we're making a right angle triangle again for the second component. Not the same like before when for the component along the y-axis it was sine theta. It was sine theta because it is a right angle triangle in here. However, now, or the perpendicular axis, we were able to say Fy equal to F sine theta because y is perpendicular to x. In this case, if we have now vector A and vector B, vector A and B will make an angle theta between both of them. This theta will always be, the minimum of this angle theta is going to be 0 degrees, and the maximum of it is going to be 180 degrees. So theta always between 0 and 180 degrees. Theta, if you go down here to the minimum, theta is going to be 0. If you take A to the other side, is going to make 180 degrees. So theta always between 0 and 180. Now, if we try to represent vector A in a three-dimensional space, we're saying that the position vector A equal to AXI plus AYJ plus AZK, and this is the Cartesian form of the vector A. To find the magnitude of that position vector, the magnitude is always equal to the square root of the sum of the squares of these components. To find the unit vector A, the unit vector A is equal to the position vector divided by the magnitude. That means you take each component and divide it by the magnitude. And also you should remember that the unit vector is equal to cos theta. Therefore, it's very important to understand how to find the unit vector. Most of the cases, theta is not given, and we will find it through finding the unit vector itself. We do the same thing for vector B. Represent the position vector in a Cartesian form, bxi plus byj plus zk, finding the magnitude of that position vector in here, and that's how you find the unit vector for B. And also remember, or always remember, that the unit vector is always to cos theta. Now, to find the dot product for this, for between these two vectors A dot B, now we are going to multiply similar or like terms. So for A, I component will be multiplied by the I component of B. It's like a matrix. Therefore, A dot B equal to AX BX and AY BY plus AZ BZ. This is the product of A dot B. Now, if we have this question in here, and the question is asking us to determine the magnitudes of the projection of the force F. This is the force F, and it's got two projection or two components. These components, we can see that they both are not perpendicular to each other. One of them is making 45 degrees with the force F, and the other along the v-axis is making 15 degrees along the v-axis. In this case, as we just said, finding the force along the u-axis similar to the rectangular components, we can say F cos 45, and that is equal to 100 Newton force applied cos 45, and that should equal to 70.7 Newton. We will repeat the same thing, and we will do the same thing for the V components or the projections along the V-axis. The projection along the V-axis, we make a right angle triangle with the force F, so that we are able to say F along the V-axis is equal to F cos theta, which is F cos 15 in this case, equal to 100 Newton cos 15 degrees equal to 96.6 Newton. This is the prerequisites, guys, that what you need in order to be able to work with the dot products. See you in the next video for more practical questions.